Hello and welcome back to Project Java. This is Venkat, and in this video, we'll be talking about literals and constants in Java. Now, before talking about literals and constants, I just want to describe or revise on the concept of declaration and assigning of values to a variable. So, in case of a declaration, what we do is we specify a data type and we specify a variable name, and that's it. That is just like declaring a variable. In case of assignment, what happens is you really assign a value after declaring a variable. So these are two different things that you need to know. Let's say ABC is of an int data type, so I can assign any value, like between its range. Now there is something known as shorthand assignment, where you put declaration and assignment in the same line. Okay, how that happens is really simple. You just write int ABC is equals 25. That's it. Now let's identify the tokens that we see here. This one is the data type definitely, and this is a variable name, and this particular value that is 25, it's a literal. Now I'll tell you what literals are, but before that let me make one thing clear. Variables and constants are two different things. So this particular variable ABC is not a constant. Here's why. Let's say in the latter part of the program I just want to update the value of ABC, so I can just use the increment operator and the value would change to 26. Even after that I can update the value. Let's say ABC is equals ABC plus 10, which makes a value of 36 being stored into the variable. But what are constants? Constants are something which cannot change, which are assigned to a variable, and those values cannot change. So in order to convert a given variable into a constant, Java provides us with one keyword which is known as final. We use this keyword not just here, but there are various and vast applications of using this keyword even in inheritance. We'll learn about all the aspects of final as we go down the chronology of our course. But for now, just this purpose that a variable can be made a constant by using this keyword final. In that case, shorthand assignment for a constant would have been final int abc is equals 25. Now in this case, now if you perform any kind of a operation like an increment operation or updating of the value inside of a variable, you would definitely get a compilation error. So this operation is not permitted after you declare a variable as final. What the Java compiler decodes when you tell that this particular variable is final is that it won't change the value howsoever you want to modify this variable. So that is a constant. Now you can definitely call ABC a constant. Okay. Talking about a literal can be any value which has been, like assigned to a variable. It it can be a constant value. It can be something, like you are inheriting from the environment, as an environment variable. So it can be anything. Now there are some literals that we need to know about in Java, so let's talk about them. Literals are basically divided into subcategories. Okay, now when I talk about literal, when we talked about data types, there were like numeric types, there were boolean types, then there were floating types. In the same way, literals are the same. So there are integer type literals, there are floating type literals, there are again boolean type literals, and obviously not to forget there are character literals. Now there is something else that we also have, and that is string literals. But since we haven't covered string by far, so we'll keep it for the subsequent videos to be talked about. Now let's decode all these literals one by one. Talking about the first one, which is an integer literal. Now for all the integer data types like byte, short, int, and long, you can use a integer value, and that is something that we will call integer literal. Now variables of these data types belonging to these data types can hold any integer value given their range is satisfying. Now, there is one thing that I need to mention, that Java also has, concepts of decimal, octal, and hexadecimal literals. So integer literals are further subdivided into these three categories, which is decimal, octal, and hexadecimal. Now, you might have a question, why not binary? Well, because I just did not mention that. Binary is also allowed in as an integer literal. Now, for example, let's say that I want to declare a decimal literal. Okay, talking about decimals first, because they are really easy. Well, the permitted digits are from 0 to 9, so well, I can have any value assigned to a variable as a decimal literal, which has its digits from the range 0 to 9, and also satisfying the range of a integer data type. So I can say 2142 is a decimal literal. Now, talking about octal literals, how do you do that? Well, it's pretty simple. You just need to know the permitted digits, which is from 0 to 7, and the literal value should be prefixed with 0. Now, many of you who write like this, like there is some number, let's say 10, and then you write 010 just for fashion, just to have these three digits. Or let's say there is some number 5 and you write 005. Let me tell you, things get different in Java with these things. You might find it a very simple topic to understand, but there are programs that I have seen getting stuck, and people getting no marks or getting 0 marks for these kind of minute errors. So anything which is prefixed with 0 is an octal literal. Mind that. For example, let me say int x is equals 010. That means this particular variable x stores a literal, which is an octal literal basically, and the the octal value is 10. Okay, now let's talk about hexadecimal literals, which is going to be a little interesting. Why? Because hexadecimal literals are used literally anywhere. So, talking about hexadecimal, the allowed digits are from 0 to 9, and also from capital A to capital F, which can also be, in lower case, but not outside of these characters. For extra digits, we can use both upper and lower case characters, so that is not a mandatory thing that you need to follow just a capital letter or small letter convention. This is one of the place where Java is not case sensitive. You need to know. You must have seen that while playing with some CSS, cascading style sheet code, you definitely specify some background color, right? And that background color is preceded with a hash symbol, and then you write the background code, which is a 6-digit hexadecimal literal. So let me tell you, you can also have a background color of, let's say, 21AF32, or you can also have a background, let's say, AFF311, and so on. So since these are not case sensitive, Java also omits case sensitivity in a hexadecimal literal, and this is the only place, I suppose. Now, what are the how exactly will you assign a hexadecimal literal to a variable? The answer is here. Let's say I have a variable int hex is equals, and then I need to mention 0x and then the hexadecimal value. Let's say 2123 and so on. You can really go about, any size, given that the hexadecimal literal in decimal does not exceed the range of an integer type. So yeah, you need to precede a hexadecimal literal with this, or you can also write 0 capital X to 123. Both means the hexadecimal literal. So the value of this particular the value that will be stored in this variable would be 8, because 10 corresponds to a decimal 8. And the value, let's say for this particular thing, let's say int hex is equals 0x 10, would default to 16. So that is no doubt that whatever literal you are using internally, they are referred to as integer types only. I hope that is clear. Okay, so given this example, this particular shorthand assignment, we can clearly see that this is a octal literal, and the compilation error that we are getting is integer number too large. Why does this happen? Because I have already told you that the range of an octal literal is from 0 to 7. The permitted digits are from 0 to 7. Okay, but what you are using here is an 8, which is not permitted, and thereby it gives you a compilation error that the integer number is too large. Similarly, you can also represent binary numbers, in a way int xyz. It should be prefixed with 0b and then the binary number. Okay. You can also mention capital B, 0 capital B, and all of this would mean a binary number, binary literal. Moving on, let's explore the floating literals. What are they and how they work? So in the second type, we are discussing about floating literals. Floating literals are pretty simple to understand. These are just for the types float and double. Okay. By default, every floating point value is of a double type. So let me write this. By default, every floating point is of double type. Double offers higher precision as well as it's efficient on modern day processors, and thereby Java chose to have the double type as like the default data type for a floating point value. Hence, we cannot assign a floating point literal directly. So in that case, we need to specify things. But just in case you write something like this, let me give you an example. Just in case you write something like this, float f is equals 26.521. Well, this is going to give you a compilation error. So you should mind this. While declaring a float type, you should simply say float f is equals 26.521 f, or you can also write f is equals 26.521 capital F. Now this distinctly says to the Java compiler that it is a float data type value. Okay, it belongs to the float data type, and hence it should be treated as a float data type only. Now these conventions you must remember, because this would really help you in shorthand assignment of floating type values. But if you are using a double, you can say double f is equals, let's say, 26.521. Well, you then don't need to specify any kind of you know character in order to represent that this particular variable f is storing some kind of a double floating type. But there Java offers one more thing, which is you can also use characters like small d or like uppercase d in order to represent this double type. So you can really write like this in Java. Actually, this is the authentic assignment that you do to a floating type variable, and you should always remember this. What will happen in this case, 26.521, the compilation error would possibly be possible loss of precision, PLOP. Now, why the loss of precision? This is because by default every floating point is of a double data type, but what we are mentioning here is a float data type. So double has a precision twice than that of a float, because the float has a single precision, so the accuracy isn't that much, and that is why you would get this possible loss of precision. This not just happens in this case, but let's say you are specifying int x is equals 10l. Well, this particular l represents a long type, like a long literal. So again, you'll get a compilation error saying possible loss of precision. You should keep this in mind. This is something that I forgot to add in the like previous slide. Now we can specify floating point literals pretty easily. Now we know how to specify double type literals as well. Now the question here would be that cannot we have a representation of floating literals in binary, decimal, and hexadecimal format? Now let me say you one thing. Floating point is only for decimal representation. You cannot use octal or hexadecimal formats to specify a floating literal. Now don't confuse, I'll give you the explanation. You might represent values of octal and hexadecimal and integral literals, but here, let's say if you are writing something like double value is equals 0x 2123 dot um, 596. This will give you a compilation error, and this will not compile actually. This is like a malformed floating literal. What do we call this? We call it malformed floating literal. So just note this, that we cannot use octal or hexadecimal formats for floating point literals. There is one more thing which is used for scientific notation and that you might need to know about, that Java also supports science students. No, scientific notation is something different. Listen carefully. You have this little e that you can use for scientific notation, okay? Now, what does this mean? Let's say you are writing something like double d is equals 1.2 e3. The value that d would store is somewhere around 1200.0. So, what does e mean? E means something to the power of 10. Like whatever you write after e, that'll be there in the power. So, it means something like this. There is another declaration that we can see just for an example purpose, which is double d is equals 0x face. Now you might have a question that octal and hexadecimal cannot be used for floating point literals, but yeah, I'm not using a floating point as an octal or hexadecimal. I'm just using it as a hexadecimal like literal, which is I'm storing into a double data type. This is an integer literal, which is clear. It is a type of an integer literal, and we can definitely store it into a double type variable as well. So there is no problem with this. The problem lies in the floating point literals cannot be used as an octal or hexadecimal format. Now let us talk about the third type, which is the character literal in Java. Now there is one thing about characters. It Whenever you assign a value to a character, let's say char ch, you need to mention this in single quotations, and then the value inside of it. Let's say I can mention lowercase b. This is the declaration and shorthand assignment of a character literal. Okay, here this is the data type, the char data type, this is the variable name, and this is the character literal. Now we can just to write this down, I can specify Character literals are single characters within single quotations. Note this. Now, there are a lot of ways in which you can actually represent a character literal. So, let me just enumerate one by one. We can represent character literals in the following way. Okay, we can represent it as an integer literal. We can represent it as a Unicode literal. Like a Unicode representation syntax would be something like, char ch is equals backslash u, and then a 4-digit hexadecimal code. Just note that this should be a 4-digit hexadecimal code only. More than this, and the character is invalid. And we can also mention it in, like octal or hexadecimal formats as well, as a hexadecimal literal, which comes under integer literal, so it's quite justified. There are only two or three ways, and obviously the like single character and like actually a character way, a character within quotes. So these are the four ways in which you can represent a character literal. Let me just quickly show you how we do that. In case of an integer literal, we already know that the range of a character data type, like a char data type, is from 0 to 65535. So we can have any integer value assigned to a char variable unless it exceeds its range. Let's say I can literally write 65534, and since we know that Unicode is 16-bit, so there'll be some value for which there is some character, and at a value of 65534, you would probably have some unknown character in Unicode assigned. Now this is obviously something interesting because internally characters are represented with the help of numbers, with the help of integers. So basically, any character value you write, let's say char ch is equals capital A. So internally, ch stores a value of 65. 65 is the Unicode value for capital A. Note this. So there is like a range of ASCII values. 65 to 90 belongs to capital A to capital Z. 96 to, I suppose, 122 belongs to small a to small z. 32 belongs to a space character, like a space, blank space. I cannot obviously uh, define it like this, so I'll just write it here, blank space. So these are the ASCII values which you can remember if you want, and even if you don't, probably it does not make any difference in the programming world. So internally, it is represented with the help of integers, and thereby you can actually use an integer literal to denote a character data type. This is one of the declarations. Another declaration is the Unicode method, which I have shown you above. You can like really write ch is equals and within single quotations backslash u, and then some four hexadecimal characters. Now I'm writing xxxx here, but you definitely need to input some characters, like something like you know the representation would be like ch is equals backslash u, um 0061. This is for small a, or you can really write ch is equals backslash u 0062. This is for small b. So what is this particular thing? This is a sort of an escape sequence which stands for Unicode, like you're denoting this in a Unicode format, and then you use it. You can also use octal or hexadecimal declarations and assignments like char ch is equals 0x face, and literally write it like this, because at the end of the day, hexadecimal is also of integer type, and character is also internally represented as an integer type. So makes a relation between hexa and char as well. Okay, like just think of it in this way: you literally write hashtag 212121, okay, in css. This particular value, hexadecimal value, refers to some particular color, which is like dull black, I suppose. And like even in css you can write the background color to be red all in string, but internally it is again represented as a number. It's a hexadecimal number that is being represented. So yeah. Oh wait, this is not red, this is black. Just in case you look at the slide and you might think hashtag 212121 is for black. And exactly not black, let me tell you, it's for dull black. Note this as well. No, there are people who would, obviously catch up on some segments of my video and then create some controversial things. I don't want that. Just to stay safe. All right. There is something known as escape sequences. You can also use them as character literals. Okay. Now, escape sequences are something like what you cannot see on the output window, or like what you cannot implement or write down in the code, but Java has something just like backslash n means a new line. Okay, let's say that you want in this output screen, um, you have printed something and then you want to go to the next line in order to print something here, but you definitely cannot press enter, and because an enter character is not available in as a character literal, and thereby you use a backslash n to denote a new line character, and in that case it would become char ch is equals, and within single quotations again a backslash followed by a escape sequence. Now there are other escape sequences as well, just like backslash t denotes a horizontal tab. Okay, just like in the word document, you go and you write something and then you press tab and then the cursor shifts some spaces ahead in the window. So in order to represent that, you use backslash t. Backslash r then again can be seen as a carriage return. Okay, then for a single quotation you can use a backslash and a single quote. Same applies for a double quotation, you just use a backslash and a double quote, and so on and so forth. We can have a different video on that one to understand escape sequences. These days escape sequences are not that much used because you can pretty much do everything with the help of text blocks. Okay, text blocks is something new which has been introduced in the latter versions of Java. We'll talk about this when we talk about string literals. I'll show you how to have a text block in your Java program. So that'll be pretty much it for a character literal. Let's now move on to see Boolean literals. Now let's talk about the fourth literal that we have for today, which is Boolean literals. This is pretty simple to understand. There are only two values and there is just one data type in which you can use it, which is Boolean data type. Assignment and shorthand assignment I'll show you here. Let's say Boolean is valid is equals true. So which means that is valid is a Boolean type variable which says that it is true. There is something that you must keep in mind. Java does not have a format where you would use 0 or 1 at a program level, like at a source code level, to represent false and true. Many other languages like Python have this kind of feature. So, just Python, if some Python users are watching this, just note that you cannot use zeros or ones, at least at a source code level, to represent false and true. You know, some example of this would mean like int x is equal 0, and then you just write a if condition and you leave it like this, and then some statements and else some statements. No, this format is not valid. This will give you a compilation error saying incompatible types, because what if accepts as its parameter is a boolean type. What it has found is an integer type, but what it expects, is a boolean type. So this is what I was talking about in the previous part of this video, that Java checks for type compatibility. And int and an boolean, no day they would be the same together. So you just need to keep this in mind. Also, there is one thing about the assignment of values. Let's say I'm writing this assignment. People say that this kind of thing is allowed in Java. Definitely not, bro. It's a boolean. You can just use true or false, nothing else. Unquoted, unfiltered, nothing. So that's it for this video. We'll be talking about typecasting in Java, which will be a really short video of, let's say, 10 minutes, where we just have a diagrammatic representation of the conversions and talking about um autocast and explicit casting, like coercion. So this would be the other video, and for this video, this will be it. So if you like this video, you get this particular video once again. Keep following this course, because I am being consistent with this course, at least, not with my sleep schedule. And I hope that this course finds you good. So please do like, subscribe, and share. Also, comment down your doubts if you have any, and I have provided all my socials to you so that you can ping me up anytime you want and throughout the day and night. So that'll be it for this video, and thanks for watching.